Hello everyone, welcome back to my channel. In this video I'm going to show you how to open up the base of the Oak Creek mill from Lemax. This one is the first Lemax piece that I've seen that has this plastic mat on the bottom instead of the Lemax foam. So I'm just going to be using this knife, also just my fingers. I also might get a lighter opener. I think this might work pretty well. Alright, well, I guess if you can just get in on a spot that the glue's already peeling, a lighter opener works really well because it's not too sharp and it has a pretty long blade. So you can just sort of go around the bottom there. And then I'll just go ahead and explain quick what the bottom of this piece sort of looks like, what it has. This one runs on 9-volt AC. The reason why I think it's an AC pump in here that's underneath the mill, which I can go ahead and show you quick. I'm gonna have to redo everything on this piece. But the pump in here, I have seen some small water feature things that do have AC power required. And that's because usually they're a magnetic water pump. So basically the blades on the inside, they don't actually have any contacts on it. So it requires an AC power source to get the magnetic fields to work on the water pump. So this here, I'm assuming, is a step-down power supply. And I'll just go ahead and plug it in quick. A lot of these early 2000s Lemax pieces had bad power regulators, so the LEDs burn out over time if you have it on too long. That did not look good. I don't think any wires are getting crossed, but this looks like it's burning out the LEDs right now. So that sound is from the water pump. And you see how that light there is turning orange? I don't think that's very good. I'm just gonna see quick also this. The boathouse light is running. From what I can see, all the lights are working, but eesh. I have done a bunch of Lemax pieces now though where I've redone all the lighting in it. So I might end up just doing that with this. It's just sort of starting from scratch. But here's a quick computer board explanation on the Lemax mill. So this one's pretty simple since it does not have any sound. And on the back side here, it's got a transistor, a rectifier, a diode that wasn't even used, and a resistor. This is another type of diode. And then 2 big resistors, which I think were overkill, but they just used it, I think, as a jumper. And basically what it does, no, it's probably almost impossible to see on the camera. Just try and bring it closer. On the back side here, these 2 wires, these 2 little white wires that are coming in, these 2 right here are power. So those go to the main AC rails of this. And then these wires are the AC pump wires. Interestingly enough, the rectifier chip just is powering this little motor over here because it requires DC, otherwise it would burn out. and the transistor on top is running the motor as well. So the output rail from the transistor goes to this green wire that then makes a junction here underneath some hot glue to the motor. And then the other motor wire is just attached here before the diode. But the diode is not used. The output rail for the diode is just left, which is dumb. I don't know why they didn't use it. Other than that, then you have the lighting, which is AC power, which is also stupid because LEDs light up much better if you have a capacitor, because LEDs will only light up on one phase. So as it's alternating current, you'll actually see the LEDs strobing. And so basically what they did is you have the input power, and it makes a little U shape to come over to these points where they did the solder for the pump. And so the green lights and this light for the boathouse are both on the same phase. So if you see one wire for these pond lights and one of these green wires for the boathouse is both connected to the same wire of the pump, which is an AC power. And then over here, it jumps with the resistor. It goes across from the U shape, goes to here. And so right at this point is where the other wires for those LEDs are connected. That's very stupid because they're different colors, and LEDs, again, will light up better if they have a capacitor, but definitely they'll also light up better and last longer if you have each color on its own resistor. So mixing green with yellow is not a good choice because those also are different. They require different levels of power. So when I saw the two resistors on this chip, I was assuming they would have put the two yellow together and the green on their own. But no, they put one set of yellow, or one yellow LED, and then the pond lights. And then on the other side, they connected one white wire here to the blue, and then they connected the other wire here across from that LED, or resistor, sorry. And then that goes in to power the main boathouse, and that's why that one's burning out. Is that one should not really be on its own. It should be connected with this other one, because if you can group as many LEDs of the same color together, especially if you have this kind of configuration, having the resistor but no actual capacitor, so you're just giving it AC power, having as many of the same color LED as possible on one phase is definitely a better choice. But anyway, hopefully this video helps anyone who's trying to do some electrical troubleshooting on this piece. It's definitely a bit of a mess. So, alright, so here's a video showing this piece before I start gluing everything back on. I've done extensive work on all the LED circuitry, and I made a custom rectifier and everything for it. I'll just go ahead and turn it on quick so you can see. Obviously the water pump doesn't like not having water. Basically you can see though there's blue lights in the pond now, and there's warm white lights now for the buildings. And what I had to do for the pond lights was I used nippers to go and cut the pins of the original 5mm LEDs that were this like chartreuse color. And I cut them, and then I used a heat gun to try and weaken the original resin that's here on each of these LEDs. and then I used a hammer and a little screwdriver to pop them back in. And then I went ahead and soldered onto the original wires as best I could to replace it with blue. In my opinion, it looks 1,000 times better because blue really is gonna look much better with water in it. Whereas before it was this greenish color. And then this LED, what I did is I heat gunned it carefully. This is plastic, so you don't want to heat it up too hot. And then I pulled it back through. And then these are new warm white LEDs. I put some tape and hot glue over it to sort of diffuse it because they were water clear LEDs. So I think that looks more homey than the yellow lights did. They're on a bit dim just because I don't want them to burn out. These should last a lot longer now than the original did. And also under here, I put in a little rectifier chip. I went ahead and cut the LEDs off of the original circuit board, and I put in one of these little tiny rectifier chips. These basically, if you have an AC power, you connect it to two of the pins on this side, and then you have the direct current output on the other side. So I connected two wires to the AC input from the switch, and it goes to the rectifier chip, and then the output goes to this capacitor, which is, let me see, I think it was a 470 UF, yeah, 470 UF and 10 volt rated. So then now the LEDs fade out when you turn off the power, and that's because of the capacitor is actually storing energy. So this is regulating the power going to the LEDs and making sure that they have a constant output. Before, when you would look at the LEDs, they strobed a little bit and it didn't look very good. So this looks a lot better now having the capacitor. And then I put a 3K3 resistor for the blue LEDs coming from the output of the rectifier and capacitor. And then I put a 1K for the warm white. And in total now, there's 2 warm white in here, 2 warm white on the inside of this, and then 1 more warm white right here. So that's a total of 5. So overall, this building is brighter now and looks just much better in general. And here is the mill with water added back in now. I used silicone to seal the LEDs, and so all of them are just nice and sealed up with silicone. I basically sprayed silicone up from the bottom to really try and insulate around the LEDs, and then I smoothed it on the top. And to re-glue the figures on the inside here, I just used hot glue. It works pretty well because it will stick underwater, whereas super glue, which I normally would use, will break off slowly over time because it's weakened by water. Hot glue though, it's not the strongest, so if these get bumped again, they'll probably break off, but it's not the worst thing in the world because you just need to re-glue it with some hot glue. And then this building here I re-glued with super glue, so it repaired the porcelain. And this building here I did with hot glue in case I ever need to remove it. And this trough I secured with some hot glue. Unfortunately, it's leaking a bit, mostly because there's kind of a bad connection with the tubing, so I might try and fix that. But overall, I think it looks 1,000 times better than it would have originally. Definitely having the blue lighting in the pond just makes it a lot more intriguing to look at. And the bright warm white inside of the buildings just makes it look a lot more inviting. It definitely is a centerpiece now for any Christmas village. because you can really see it. So I hope you enjoyed this video. If you have any questions about this, just let me know. I'm happy to answer any questions you might have. Thanks for watching, and be sure to check out the other videos on my channel.